So in this video, we're going to look at molecular formula. It's still part of CC9, the calculations topic that can come up on paper 1 and on paper 2. So just a reminder of the difference between molecular formula and empirical formula, which is the one we were looking at in the previous video. Molecular formula tells you exactly how many atoms are present in a molecule. So I've written here the formula for glucose, C6H12O6. It tells me I've got 6 carbons, 12 hydrogens and 6 oxygens in a molecule of glucose. If I want to write the empirical formula, I need to simplify these numbers. And to do that, I divide across by the largest number that goes in evenly to all 3 numbers. In this case, that is going to be 6. So if I divide by 6, I get 6 divided by 6 is 1, 12 divided by 6 is 2, and again 6 divided by 6 is 1, and I convert to the empirical formula, the simplest whole number ratio. Another example below, C4H10, if I divide across by 2, I will get C2H5. So molecular formula, the actual number of atoms, empirical formula, the simplest whole number ratio. In this video, we're going to look at calculating molecular formula when you are given the empirical formula. So to go from molecular to empirical is quite simple. You just divide. To get from empirical to molecular formula, you're going to do the opposite. So you're going to multiply. But if I just gave you the empirical formula by itself and told you to write the molecular formula, well, you don't know what number you need to multiply by. So just being given the empirical formula by itself will not enable you to get back to the molecular formula. You're going to need to know what number you must multiply by in order to be able to get back to the molecular formula. So when you're finding molecular formula, as well as having the empirical formula, you must have one other piece of information. And that information is the relative formula mass of the full molecule. The relative formula mass of the full molecule. Taken together, these two pieces of information can be used to find the molecular formula in 3 steps. And I'm going to show you a worked example that I have done here. Okay, so in the question, you're asked about glucose, which is the one we've just seen, and you're told the empirical formula. So you're given the empirical formula straight off, and you're told that the relative formula mass of the full molecule is 180. So they're the 2 pieces of information that you are given. In step 1, you must take the empirical formula, so that's what I've got there, and you must find the relative formula mass of the empirical formula. Okay, so if I look at my formula, I have got 1 carbon, 2 hydrogens and 1 oxygen. From my periodic table, I would see that carbon has a mass of 12, hydrogen has a mass of 1, and oxygen has a mass of 16. 1 carbon, so I've got 112, 2 hydrogen, so 1 times 2, and then 1 oxygen is 16. Add all that together and I get 30. So I take my empirical formula and I find the relative formula mass and I end up with 30. That is step 1. In step 2, I divide the relative formula mass given in the question. So that was 180, which I had highlighted in orange. I divide that by the answer to step 1. So there's my 180 taken from the question, and I divide that by the answer to step 1, and I end up with 6. Okay, so and when you're doing this, if you get confused about which way you're supposed to divide the numbers, the number has to end up as a whole number. You're not going to get a decimal. So if you did it the other way around, you would end up with a decimal. It has to be a whole number. So it's going to be the bigger number first, divided by the smaller number. And then in step 3, you are going to take the empirical formula that you are given in the question. Okay, there it is again. And you're going to multiply it by 6, which is your answer to step 2. So we saw that here to get from the molecular formula to the empirical, we divided by 6. So I know I need to multiply by 6 to get back, but without being given that information, how am I supposed to know that I multiply by 6? If you're given the formula mass, you can then do this step 2 calculation to find that number 6, and then once you've got that number, you multiply to get back to where you started, C6H12O6. Here I've got another example of the same thing. Again, I'm giving you in the question the empirical formula and I'm giving you the relative formula mass. This time that's to a decimal, to relative formula mass. The formula mass of the empirical formula is worked out for you below. So carbon, again, has a mass of 12, hydrogen has a mass of 1, and bromine has a mass of 80. So I've got 2 carbons, so it's 12 times 2, 4 hydrogens, so 4 times 1, and 1 bromine is 80, and I add all that together. I always add when I'm finding relative formula mass, and I get the answer of 108. I then take my number from the question and I divide it by my answer to step 1, and I end up with the number 2. And then my last step is I will take that empirical formula again, I will multiply by 2, and I end up with my molecular formula. So with 3 steps, they will be the same each time. You'll always be given 2 pieces of information. You use the formula in step 1, you find the formula mass, then you divide the number you're given in the question by your answer to step 1, and then you multiply your answer for step 2 by the formula from the question. Okay, so same 3 steps each time. You definitely are going to need to practice this. So on the screen, I will leave that worked example for you, and I want you to do practice questions 1 and 2. In practice question 1, I give you the empirical formula and the formula mass. So those 2 pieces of information are given to you straight away in the question. In part 2, you have to calculate the empirical formula yourself. So if you remember from the previous video, to calculate the empirical formula, you're going to draw a table. You're going to have carbon and hydrogen in your table. You'll put the mass below. You'll put the the atomic mass from the periodic table. You'll divide and you'll simplify the ratio. So that whole table process must be done in part A. And then once you've got your empirical formula, you can use the formula, your answer for A, with the number you're given in the question to find your answer for B. So because I haven't included, I'll just write it here. The mass of carbon is 12, the mass of hydrogen is 1, the mass of oxygen is 16. They're the numbers from the periodic table that you will need. So press pause, have a go by yourself, and press play when you're ready for the answers. Okay, so here's the answer for 1A. You're given CH3 as the formula. You must first find the formula mass, so 12 for carbon, and I've got 3 times 1 for hydrogen. The formula mass is 15. I'm given the number 30 in the question. I do 30 divided by my answer for step 1, and I get 2. And then I take the formula that I'm given in the question, I multiply by 2, and I get the answer C2H6. For 1B, similar situation, C2H6O is the formula from the question. I find the formula mass, so 12 times 2 for carbon, 6 times 1 for hydrogen, 16 for oxygen, a mass of 46. The number given in the question is also 46, so it becomes 46 divided by 46 equals 1. Then I'm taking my formula, multiplying it by 1, and I'm getting the exact same answer for my molecular formula. So that can happen, and you can get the same answer for both. In part C, again, I take so in part C, again, I've got my formula. Carbon has a mass of 12, I've got 2 hydrogens, each with a mass of 1. Oxygen has a mass of 16. I add that together and I get 30. The number given in the question was 60, so it's 60 divided by 30 equals 2. Then I take the formula, multiply by 2, and I get C2H4O2. In B, you had to work out the molecular formula for yourself first. So in 2A, you work out the formula. So you're given carbon and hydrogen as the 2 elements. You're given the mass of carbon and the mass of hydrogen. From the periodic table, the mass of carbon is 12 and the mass of hydrogen is 1. So my first step is to divide. These are the 2 numbers I get. I look at these 2 numbers and ask myself which is smallest. 0.714 is smallest, so I divide both numbers by the smaller number, and that allows me to simplify my ratio to 1:2, so I get my ratio in a whole number. The 1 corresponds to the carbon, so that's 1C. The 2 corresponds to the hydrogen, so that's H2. CH2 is my empirical formula. Now that I know my empirical formula, I can complete 2B. So I start by getting the formula mass of my empirical formula. Carbon has a mass of 12, there are 2 hydrogens, each with a mass of 1, so you end up with a formula mass of 14. The number from the question is 70, So it's 70 divided by 14 is 5. And then I take my empirical formula, I multiply it by 5, and I get C5H10. Okay, so those 3 steps are always going to be the same for finding molecular formula. Make sure you know them.